Oh, let's start. Let's start. Okay. What's that? What's that? Why? My head is so big. No one tell me, huh? What I'm doing? Sorry, I get lost. Okay, yes. Let's start. So I should have sent you the exam paper through the WhatsApp. Because like last time I just put it in the share folder in the Google Drive or Google Classroom. I think it may not be that appropriate because you may know the others' performance. So because of the privacy, this time I use this method. So yeah, I just need to send you one by one. It takes a little bit more time, but it's okay. If it is better, right? So first, I want you to open your file at the same time with the lesson today. If you have more than one device, okay? If you have one more device, you may just open the file at the same time, so that you know what questions you did wrong. And whenever we go through an exam or we go through a homework or a test, the most important thing is to review on our mistakes and be able to prevent the same mistake happen again or to clear our misconception. So this is the best way to handle the subject through exercise or test to learn. Okay, it's the most effective way. Now I will talk about how to calculate your final grade. So actually I also post in the WhatsApp group. For MC questions, 30 mark, full mark, it takes 35%. So that's why you need to use your MC score times 35 divided by 30 plus your long question, which is 65%. You use the long question score times 65 divided by 80. Now these 80 and 30 are the full mark of that part. And then when you add together, it will become a score out of 100. So this is the final grade, final mark, I mean, the out of 100 in the examination. So surely we have also the GP mark, and the GP would take 40%, and this examination would be 40%, sorry, 60%. I would do some adjustment on the GP mark. We did some tests, and I will try to adjust according to your exam result also. Surely, if you improve a lot in the exam, you will go higher. But if you did worse in exam, I won't deduct your GP mark lowering. So as a result, you will only get a better mark. I will not post the final marks here because I don't want you guys to know the mark of the others, because some of you may feel very embarrassed if the mark is not really high. So please understand, if you want to know your final marks, you may just let me know. I may message you one by one, okay? But give me some time. Don't ask me, don't expect, send me immediately. I tell you after 1 minute, I need to check and tell you individually, okay? Now, so that would be your grade, final mark out of 100, including the GP and not in the examination. And what would be the grade when you'll be having the A, B, C, D, E grade in your report cards actually. So the A, B, C, D, E grade would be like this. Oh, sorry. You put this right. If you score more than 75, you get level A, you get A, okay? If you're higher than 65, you get B. If you got 55, you got C. 45, you got D, now see, only 35 mark will make you pass. Understand? E, N. If you get more than 20, you got F. If you are between 0 to 20, you got barely a U. That is how the grade conversion. You think, oh, it's so easy, 35 mark, I'll get a level, get passed in from only 35 mark. Yes, it's actually the real situation. It's even worse. If you got 30 marks, you can get level 2 already. I told you many times already, 90% of the candidate, they would get level 2 or above. Okay? Almost 50% would get level 4 or above in this subject. So that's why you can imagine if you are above this, actually you can get level 4 easily. Okay? So this is level 4 line, and this is level 2. In fact, this examination would be a bit easier. The reason is you still haven't learned the book 4, book 5, and E2, E3. There would be many other topics at the same time. So I would predict that you guys would be having lower score if you really take all the things all at one time. This is common. I'm not saying that, I'm not looking down you, but from my experience, just like this year Form 6, their score would be lower than Form 5. It's common. It's common. Okay? Now, so that is something you should be aware. We have to be able to handle many topics at a time. Okay. Now, so let's go through the answer question by question now, starting from the MC questions. Okay. Now let's go back to the other screen sharing. Get ready, especially for those who did wrong. You need to be clear about where you can handle that in the later time. Okay. Okay. Now, so let's start. Can you see that? Would it be too small? Because I may need more. I may need more space to write. Okay, now for this question. So this is a calibration graph of a thermometer using the resistance to estimate the temperature. So in handling this straight line calibration, we may find the slope. Okay, you may make use of the slope to do this. First, I may find the slope of this segment. This segment, okay, now write down the slope, which is equal to 170 minus 50, which is coming from this point. 170 minus 70, which is the height. Divide by the width, 20 minus 80, okay, 20 minus 80. Now from this calculation, you may have 120 divided by -60, so that's why you have -2. So this is the slope of the curve, the whole segment, -2. And then, now the question is asking for this 100. Okay, it automatically link up with another value t. So I would be trying to find the slope of this segment. Okay, this slope for the red part is equal to, again, we use this height, which is 100 minus 50, divide by this width, which is t minus 80. Okay, and this slope should be the same. These two segments are on the same straight line, so that's why this slope is also equal to negative. Okay, then I may make focus on this equation. So 50 is equal to -2t plus 80. All right, you need to be aware of this negative sign. When you put this on the right hand side, you just, oh sorry, see mistake here. Mr. Love going around. It should be -t times -80, right? So which is equal to 80 equal to -2t plus 160. And then 2t equal to 160 minus 50 equal to 110. Isn't it? So at the end, you may just use T equal to 110 divided by 2, which is 55 degrees Celsius. All right? And yeah, this is the answer. But in fact, you may not need to do so complicated calculation to get the answer. The reason is, you know 100 is lower than the middle a bit. When you draw the line here and find the T here, this is called graphical method. You may use a graph paper to do that. You can raise up your hand to get a graph paper. In fact, whenever you got some calculation problem, you think graph would help you, then ask for graph paper. And this value is actually larger than the middle of it, right? So that's why the middle point here should be 50. So it should be larger than 55, and this is the only answer you should pick. Different method for you. Calculation or graph paper, you may pick the one you find comfortable, okay? So that is the answer for the first. Okay, second one. Same question is, which of the following statement are correct? It's about temperature and average KE. First, we must understand the definition of temperature. How is it related to the molecular view? Okay, molecularly, which is the average KE of particles. This is what temperature definition is. So second one is average KE of particle in liquid, always larger than that in solid. Most of the time it is, but it's not a must. The reason is, you may just imagine we have a beaker of ice water. Okay, ice water. It's melting ice, so that the ice is 0 degree. The water is also 0 degree. They have the same temperature. That's why they should have the same average KE. So that's why this statement itself is wrong. The solid and liquid could be having the same average KE because at the melting point, they should share the same temperature. So that's why number 2 is wrong. It's not always. It's usually only. So usually, you know, in learning science, usually it's not worth to mention. We want to mention something always happen or yeah, like this. And the third one is, when the temperature of the object is uniform, would it be all the particle having the same KE? Is not possible. That is only average KE would be having constant value at the same temperature. You know, there's so many particles. There's constantly some particle would be having larger temperature and larger average KE or less average KE. So it's not possible for all molecules having same KE. Only average would be the same. So that's why the third one is wrong. So answer is 1 only. There's no 1, 3 either, right? Neither. So the only answer you should pick is 1 only. If you know number 2 is wrong. Okay, that's the answer for number 2. I spent too much time on this. Okay, let's continue. Number 3. Now you're heating a liquid. You're heating a liquid X, 2 kg, and the heating time is 10 minutes. And the temperature rise is from 20 to 30 seconds. So that's what we have. Mass equal to 2 kg, right? The time for heating is 10 minutes. I converted in seconds. Okay, 10 minutes is 600 seconds. And the temperature rise is from 20 to 30, which is delta T equal to 10 degrees Celsius. Okay, delta T is the change in temperature. And then there is a power here. Power is 100 watts. So that's the information we should have. Together with this 1000 joule, I will talk about this energy loss. Normally, we will write an equation like power times time equal to mc delta T. Now notice that whenever we write this equation, we put this equal sign. We have an assumption, which is the left-hand side is equal to the right-hand side, but what would make this happen? The assumption behind is there's no energy loss to the surrounding. so that the energy provided by the heater would all be absorbed by the liquid X. Unfortunately, this question is not really having no energy loss. There's 1000 joule energy loss in this case. So that means the energy provided by the heater would be partially equal to the liquid X and also to energy loss. That's why you should add 1000 here. Yeah, it's like you plus or minus. You need to be clear. So now it's energy loss, so that's why energy provided would become two parts. That's why you add them together. So if you can write down this equation correctly, you may just put the numbers there. 100, this is 100 power times the time, 600, which is equal to mass unknown C, temperature change is 10 plus 1000. So on the left hand side is 60,000 plus, equal to this one, 20 times C plus 1000. So it's just like easy math, right? You use this value minus this value and put it on the left hand side, it's become 59000. This is the energy actually being absorbed by the liquid X. And on the right hand side, if you 20 times C. So you may get this 29000 divided by 20. So that's why you pick the answer A. Is it okay? So you must check and see if you understand what is going on for this question. Especially you put the right position for this value, 1000. Okay, let's move on. Oh, I pressed the wrong button. Okay, let's do it again. Something wrong. Sorry. Okay, that's funny. Question 4. So we talked about this in the revision also. There will be different questions being asked, and the first one is about the melting point. The melting point, you may check with this height. Is solid A having melting point 120 degrees? So this is A, right? This way is correct. Number 2, specific latent heat of fusion of solid B is greater than A. You may check with this is the time required for change of state. If it takes more time, that means it requires more energy. So that's why number 2 is also correct. You see that the B is having larger width here. That means it's more difficult to melt. That's why the specific latent heat of fusion of B should be greater. Like the third one, which is specific heat capacity of solid B. That means we are comparing this segment. This is solid parts. B is greater. That means we expect B is more difficult to rise in temperature. It takes longer time or it rises slower. But from the curve, you see A, it rises slower for A. Agree, right? It rises slower for A, which means A should be having larger specific heat capacity. So answer is C. This is wrong, but we're looking for which one is incorrect. So that's why C is correct. Okay, this is C. Let's continue. We have only one lesson, so we will stop at 15, isn't it? But let's continue. Okay, question 5 is easy. Now you have a liquid which is at 20 degrees Celsius. That is liquid. You want to know whether which of the following will be liquid at 20 degrees. And liquid is somewhere below the boiling point and higher than the melting point. So 20 degree, you put 20 degree here, is somewhere in between for the substance N. So that's why substance N is correct. But for 20 degree, it's higher. This 20 degree is higher than the boiling point. That means in the substance M is above the boiling point, it should be in form of gas. And for substance L, 20 degrees is below the melting point. Below the melting point means it should be solid. Okay, so only this substance N would be the liquid. So answer is B for boy. Okay, now that's the answer for B for boy, huh? Okay, next. Question 6. Question 6. This question we are looking for the average velocity. Now, before you do the questions, you don't need to think that much. You just need to find out average velocity. It has a definition which is equal to displacement, total displacement, divided by total time. I guess all of you should be able to find out the total time should be 9 seconds, but the total displacement should be these two areas. So from t equal to 0 to 6 seconds, this object is going backward. And then from t to 6 to 9, from 6 to 9, it is going forward. This 3 seconds is going forward. So that's why if you look for the displacement, basically you're looking for this distance. This is displacement. So that means you need to use this area minus this area. I call this is area A and this is area B. So displacement is equal to area A minus area B. Now, so we need to include the sign in doing the area. All right, no need, just tell me the value, it's okay now. What's the area A? So you may just find that by the upper length, 4, plus lower length, 6. 4 plus 6, upper length plus lower length, times height, the height is 8, and then divide by 2. So which is the area of the lower trapezium? And then I would minus this upper area, which is base 3 times height divided by 2. Okay, so altogether you may find this 40 minus 15, which is 25. You go backward by 25 meters, it should be negative, okay? But anyway, I just find the value is okay in this question. So go back to this part. This should be 25 meter divided by totally 9 seconds. So that's why the answer should be 8. Okay? So that is how we handle this. Find the total displacement divided by total time. And the total displacement we found by using the area of the curve, VT graph. We found displacement by the area. Very good. Any question up to now? Are you sleeping? No?
No, sir.
ABC. Good, good, good. Hope everyone would be really trying to know what's going on, especially those you did wrong. Okay, number 7. Now this is a graph showing the variation of the displacement against time. This is ST graph. If you pay attention to the revision lesson, I actually give a very similar question to you. So you may see that now, is it X is slowing down? Like from the ST graph, you find whether it's going fast or slow by the slope. You check the slope is actually getting flat. So that means it's slowing down. The slope is the velocity, so it is slowing down, is correct. Secondly, are they travel the same distance within the same period of time? Like remember, again, this is a ST graph. This is ST graph, that means at the end point, the value would be their final displacement. And you see that they meet at the same point. So that's why they should have the same displacement, same distance travel. Correct. And thirdly, is the velocity y is greater than x at point t? So that means you only need to find out the slope at the end point of these two curves. Now I use the red one for the for the y. The slope is the same. You see that the slope is the same. This is the slope of y, but for x, the slope is here. Obviously, y is having larger slope, right? So that's why it's also correct. Answer should be D. Bye, sir. Bye, sir. Okay, so that's the end for today. I will upload this video also. Okay. So bye-bye. Take care. Let's continue tomorrow.
Bye, sir. Thank you.
Okay, take care. Bye.
Yeah.
Bye.
Sir, so we can know our short question result by asking you?
Yes. Yes, you may let me know. I'll tell you the grade. Yeah, message me, but I may not be able to answer you quickly because I keep having lesson and meeting. I will let you know later.
Thank you,
Bye-bye.
sir. Bye.